Hello, sir. Are we live?
Yes, we are live.
Okay. Shall we start?
Yes, I think we can start.
Okay. So good afternoon, everyone. Welcome to the Build-A-Thon session on this roundtable for the 2022 AIML challenge. Today, we will be discussing various technical aspects of this Build-A-Thon challenge, and the haptics and MEC team at IIT. They'll all be addressing the queries from the participants and how to access the data sets, how to understand the problem statement. Some of these aspects would be addressed here. I now hand over the session to the haptics and MEC team at IIT Delhi. Over to you, team.
Okay, so welcome all. I'm Gaurav Shukla from the MEC testbed team. And first I'd like to share the screen and want to give you a brief introduction of our landing page where all the information is kept. So I hope you all are seeing the landing page now. So this is our landing page. So you can get all the information over here related to the Build-A-Thon contest. So these are our partners. Indian Institute of Technology, Delhi. So IIT Delhi is technical leader for the regional ITU India Global Challenge. And India EU ICT is funding and supporting this challenge also. Whereas TSDSI and ITU is promoting this challenge. And the winning team submission will be entered into the ITU Global Challenge. So this is the overview of the Build-A-Thon. You can go through it here. And these are the problem statement. Again, you will find the problem statement here, mentioned over here. So you can go through this problem statement as you already know about, aware about it. So they are mentioned here. And the important section is event announcement, where you can find all the related dates and important dates, which is the submission date and which is the declaration of result and Build-A-Thon. All these dates are there. And all the previous links, past events that have happened, that links are already there. So problem is stated, a sample data set is recently been uploaded. So you can use this data set to download and work around your problem. So all the submission detail will be soon be coming here. So this is our landing page for Build-A-Thon. So all the important information we'll keep on posting here. So you can get it from here. And so this is the contact details of, so these are the two emails. So whatever the queries that you are having can be sent to these emails. So also we'll be in touch with you with these emails only. And then I start a bit about this MEC testbed that we are having. So this is the MEC testbed that IIT Delhi has developed, a MEC testbed integrated with IB code, confirming HC standards. So the application developed by the selected contestant will be tested on the testbed with actual hardware. So the application that you will develop, the solution that you will develop will be tested on this testbed with the real hardware. So I'll give you a brief introduction about the testbed. So I'll share another screen. So I think this PPT is visible to you now.
Yeah.
Okay. So this is about edge computing. So basically what happens when normally in normal connection, we are connected to the cloud. The client is connected to the cloud that is being shown here with the green line. So what is there is a latency issue, and furthermore, there's a overhead in the cloud for all the computation. And so for this purpose, we want to bring something closer to the air, closer to the radio station. So now you can see with this red line, so there is something, one server which is very closer to the radio station. So suppose if all the computation or partial computation that can take place here, so that will reduce the latency here, because this is going through this core network with external network to the cloud, while it is directly connected with the radio network to the edge server. So this reduces the latency to something like haptics applications, which is latency centric in some cases. So that can be used here. So we are having this testbed setup here at IIT Delhi. So basically, this is a combination of multiple efforts with various teams involved, like IIT Bombay, CIVIT, and IIT Delhi. So we have along with CIVIT and IIT Bombay, we have developed this testbed. So part of it has been developed by CIVIT and IIT Bombay. So this is the whole setup that we are having. So we have this RAN emulator. So these are the entities of the 5G core as well as the MEC system. So we have this RAN emulator and then 5G core and then CLCM, MECO. So this is the whole setup. But what I would like to say that so the applications that will be developed by the participants will be tested over this test bed. But participants need not worry about all this setup and everything, because ultimately it boils down to client application, cloud application, and MEC application. So I'll be referring to how the application deployment is done in MEC environment. So I'll be very short in the interest of time, because we'll mostly be covering the haptics part of and your questions about this, but I'll just briefly introduce. So the application can be deployed in 3 sections, like one at the UE level, which is client level, one at the edge level, which is closer to we also call it near server, which is closer to the radio access network. So the distance between the geographical distance or the latency is very much less here from UE to the edge level. And there is this cloud server, which is fast server. So application can be deployed in 3 ways. So we can develop what is more important, what is critical can be deployed at the edge level, whereas whatever be the normal procedure, normal computation that can be done at the cloud level. So here in this slide, you can see, so this is the robotic hand. This is the haptic glove. And so whatever there is a normal connection between from client to the cloud, from haptic robotic hand to the haptic glove. But see, a constant, so for intent prediction and critical events that can happen, like the slip of, you are holding something and it on the onset of the slip, that can be detected at the edge only, and edge can send so this is very latency centric this thing, that on the onset of the slip, we need quick response from the system so that we can hold it back. So this kind of things can be deployed at the edge. So this is, but I still say that, I mean, you need not worry about this because later on we'll testing this on the this real infrastructure with on the test bed. But this is very simple. You need not worry about the what about doing the system is there, but you only have to concentrate upon the way you are doing it. So you only have to concentrate about the application itself. So that can be deployed later with very low, I mean, overhead. There's nothing like this is very complex system. So I'll be summing it up now. So uh,
Just a second before that, we just wanted to know that the funding has been done by India EU ICT collaboration. They are funding for the workshops as well as for your trip, the winning team's trip to EU. Thank you.
so So I'll be handing over not to Munib. So Munib, can you please take over and give the details about the data set and the haptics and the haptic setup and the software that we are using, and further take on the questions from the participants. Thank you.
Am I audible? Am I audible?
Yeah, we can hear it.
Oh, so hi, good afternoon, everyone. Thank you, Gaurav. So I would request all of you to open this link. That's I suppose it's the official link for this contest. If my screen is visible, right? So I would be talking about the data and the format that we have. So for problem statement 2, that is essentially uh, object detection. So what we have done here is that we have these kinds of features. So when an object is held by the robot, so the robot records its angular configuration and the forces applied. I mean experience on its joint. So it will start from J0 to J15 as you are seeing, right? It's visible. Yeah, and then there is a weight feature which corresponds to the weight of that object being held, and finally there is a label corresponding to the object. The metadata is listed over here for any of you who wants to explore more about these features. This is about problem statement number 2, where you have to detect the object. Okay, so regarding problem statement number 1, where the objective is to estimate the force. So in order to achieve two objectives, that the object not be slipping and the object not be crumpling. In this case, the features slightly vary. The common features here are that the forces experienced and the angular configuration will remain same, so it will run from J0 to J15. Here we are introducing size of the object as a feature, which is essentially its dimensions in centimeters, so that object can be. Um, we have fixated 13 different kinds of objects for this, so this will essentially contain the size of the object. It will also contain the weight of the object for you to estimate the force, and corresponding labels would be whether the object is slipping or crumbling. So based on these two objectives, you'll have to determine the force estimated so that the object does not crumple and it does not slip from the grid. So next I would like you to go over this link, which is essentially a data set. It contains samples so that you could have a head start with the modeling approaches. Right now I'm opening the sample data set for force estimation. So yeah, is it visible? So it's the same thing with numbers. So here we have these many features. Uh, Going to the right, we have corresponding to labels. So these you will have to on the basis of these two, you'll have to estimate the force. Okay. So regarding task number, problem statement number 2, we have a similar sample data set. You have to download it, open the sample.
No,
So
that
that
is
you
the
could,
control point.
sorry, sir, is there a question? Is there a question? I'm hearing some kind of. Okay, so I'll continue. In this case, we have the joint entity configuration of the force experience. So the objective here is to determine the object. We have a weight vector associated to, I mean a weight real value associated to each object, and then we have to predict the object types. So in this case, we have 13 different object types, and you would essentially have to use these features to predict the output as the type of object we have. Okay, as you're seeing, the weight of the object is varying and the size of the object is varying. So you should expect that this data will keep on changing for different kinds of objects, and this data will be similar to this distribution only. Just a second, I think we have a question. Ma'am, Pili ma'am, do we have a question or something? I'm hearing some voice in the background. Okay. So that's it from my side. I think I'll hand it over back to you, Pimi. If you guys have any questions, please drop it in the chat box or just turn on your mics so that I could be able to answer your questions. Okay, so I'm expecting that there are no questions regarding the data set, so I would like to hand it over to the
Munib,
panelist. Yeah.
Munib, this is Vishnu. Can I ask a small question regarding this data set? The fourth and fifth items in the problem statement 1. Fourth one is 0 or 1 denotes whether the object is slipping. That is continuous. It is slipping or not. Okay. And the crumbling, whereas the crumbling is actually past tense. It has already deformed. A value of 0 denotes not crumbling, and value of 1 denotes crumbling. So can you please explain whether this is a continuous process of slipping, or is it already slipped and fallen down? Similarly for crumbling also, please. Is it already crumbled, or is it in the process of crumbling?
Okay. Yes, sir. So that's a good question. So since the data, if you could look into the samples of data, they are instantaneous, right? So for a particular sample taken at a particular timestamp, the process overall from if you could see, from a high level configuration, the process is that the object is slipping, right? But the label of the data itself is either 0 or 1, so it's a binary thing that it is slipping or not slipping. Okay, so it's not a real value or something. So expect it to be integer 0 or integer 1. Same for crumbling, although in this case crumbling is slightly past tense, yes. So the object has crumpled here. So that is why we have explicitly mentioned the verb has there in order to mention that,
Okay, Munib, I will add a couple of comments here for Vishnu's and other people's benefit. So what is going to happen is these are samples at time instances. So if there is a slip at a particular instance, it is tagged as slip, but that does not mean that the object has slipped. In the eventual analysis, some number of consecutive slips will constitute as the object slipping. Similarly, some number of consecutive crumplings will, along with the new dimension, be the measure for crumpling levels. So this is an instance-based Boolean indicator whether or not a slip happened in that particular measurement. It does not represent the overall slipping of the object. For that, there will have to be a consecutive number of slip events.
Very good. Yes, I think now it is quite clear. Yes, thank you. Yeah, I think it will be good to update the description, Munif, with what Professor Burgess just now explained. Because if you look at the problem statement description, it says only to detect the shape of the object. That is not correct, I think.
Okay, sir. Thank you for your comments. I will update this.
Thank you. Thank you. Yeah. One more quick question, Munib. The frequency of the data collected, what was that frequency that you have in the data set? How often it is collected and reported?
So the data set that we have collected essentially has to correlate with the frequency of the ROS on which we would eventually calculate the data. So by default, the frequency for right now is 10 hertz. So we collect 10 samples every second.
10 samples every second. Okay, thank you.
Yes.
Thank you. Yeah.
Yes.
Thank you, Munib. Are there any other queries from the attendees?
Somebody has raised the hand, Timmy. Please check.
Yes, Mr. VIP. Somebody raised their hand. Huh? Your query, please. You can even put your query on the chat box. Any further queries related to the data set or the mentors or clubbing of the teams, anything you may ask. Ms. Vinti has requested Munib to kindly put up the data set again.
I will be sharing the link, I guess.
With further explanations, please.
further explanation. So could you be clear, Binti ma'am? So do I have to explain you these things in once again, or is there any question specific to the data set?
Yeah, if you open Maniba, I will help. If you display it, I can help.
Just a second.
Yeah, she is basically seeking some explanation with the context that Mr. Vishnu discussed and Professor Lal.
So yeah, so I would start. Vishnu sir, I would start. So uh, there was a query that slip corresponds to either of the two binary outcomes, right? So either it's slipping or not slipping. But as an eventual experiment, you could see slipping as a continuous process, right? So in this case, Vishnu sir raised a query that there should be some metric as to calculate the slip, right? So interestingly, there is a metric to which Professor Lal said that slip will be measured as a continuous process of n such events. So one such instance could be coupled with many such instances in order to categorize if the object is really slipping or not. I think I'm clear with this. Vishnu sir, please add something.
Yeah, the yes, I think the explanation is correct. Only thing is, I mean, we don't know if the object has really slipped completely or not, right? Because
Yes.
because as Professor explained, you see a series of ones. That means it is slipping, and finally, whether it has completely slipped or not, that we don't know. That is unknown, I believe. No.
Yes, sir.
Okay.
That's
Okay.
correct, sir.
Okay, I guess it is the same thing with the crumbling also, or is it different logic?
It's same with crumpling also, sir, because
Okay, okay,
there may be some
okay.
noise pertaining to a particular event of crumpling, right? So,
Right, yeah, yeah.
right?
Okay, okay. Yeah,
So it could
understood,
be also.
understood. Right, yeah. But in this problem statement, should we worry about, in this particular problem statement, I'm saying, there should we worry about crumbling at all, because the problem statement is about slip detection.
No, sir. They would have to take care of crumpling factor also, because what I mean, what difference does it make if the object is not slipping but the object has crashed, right? So for real world objects, this might be tricky. So we are seeking here some kind of a modeling approach that tackles both these problems simultaneously. But regarding the evaluation criteria, we might set a we might you know do some collective analysis of n number of units of those instances and predict whether the slipping or crumpling has taken place. But that's for the evaluation part. It's not essential right now. So yeah,
Understood.
but
Okay,
modeling approach
okay.
will
Yeah.
combine both. Have
Okay,
to
okay,
tackle both
understood.
these
Yeah,
problems.
yeah, yeah. I suggest to, in the title, please update, because it may not be clear to the participant.
Let me see. Let me actually see. So problem one is slip. No. So yeah, we'll have to rename this. It's not slip detection. It's force estimation. And
Right,
yeah,
right. And
it's
also
ignored.
the
So
third bullet, Mani, the third bullet, you see, it is to detect a shape that's not correct. If
that's
you
not correct.
please,
That's not.
yeah, yeah. If you update exactly like what you mentioned, it's both slip as well as crumbling. Both are got to be done.
I think this is a typographical error from Gaurav sir. It has been, I think, copied twice than once.
No worries, no worries. Yeah,
Yeah.
yeah, no worries.
Okay. Gaurav sir, please take a note of this. This is some.
Vipul is asking some question. Please check.
Read out the question.
He's asking regarding the force, if whether it is a resultant force or the XYZ coordinate.
Yeah. So this is a good question. So you would have seen that in the simulator we get get three different components of forces on each joint, right? So I think this question follows that. But on the actual hardware, we just have a resultant of those forces along the separate three axes. So in this case, we have taken a resultant force. So if you want to decompose it in your modeling approach, that's fine for us also. But this would be the resultant force along the x-axis, y-axis, and z-axis. I hope that answers the question.
Thank you, Munib. Also, Munib, Vinti ma'am wanted an explanation via the Excel sheet. So if you could just relate the context with that. Cannot hear you, Munib. Munib, you're not audible.
Am I audible now?
Yeah, now you're audible. We can see your screen. Please continue.
Oh, I actually don't know where I lost you. So fine. So I could start. So here the robot has 15 joints, right? So then corresponds to which we have an angular configuration on that joint as well as the force experienced on that joint. So this would essentially be JI position and JI force, where I refer to the joint number. So this runs from 0 to 15 for the 16 joints of the robot we have. Following this, we have the size of the object being held. So the size of the object, its geometry basically is the dimensions of that geometry are written here. So if it's a cube, it will be 3.5 cross. Let's say this corresponds to the dimension in centimeters. So for a ball, we would have a radius, and for a cuboid, we have something like this, right? So apart from size, we also are adding the weight of that object in kilograms. And the label of this data would be, so this one sample corresponds to an instance taken at 1 unit of time at some point of time, right? So corresponding to which there is a slip occurring or a crumpling occurring. So the modeling approach would be such that the slip does not occur as well as the object is not crumpled, right? So this is regarding task one. So is there any question regarding the problem statement that corresponds to force estimation?
Can we assume that the unit is Newton, right? For the force, or
Yeah,
is it something?
yes, sir, the default unit is Newton.
Do we know what kind of this is what kind of object, or that do we have some indication of that?
No, but that would give a peephole, right? So we are not disclosing the type of the object. Obviously, the size should give you some kind of an estimation, right? But we are not, let's say, discussing about the friction that has occurred. That would give some kind of an insight about the object. So this is
Okay.
those kinds of things have to be predicted by the model if that it works for that that solution, right?
Okay, but all this is for different types of objects, or is it for similar type of object?
Yeah, so there will be a similar kind of there will be an instance which it's only a combination of instances, right? So for this case, for showing the sampling data, we just picked up three different data samples across three different objects, right? Just to in order to showcase what the data would look like. Otherwise, this would be a continuous data. So obviously, so this timestamp would be corresponding to one object type, and following it would be the same object type only. Okay.
Okay. So basically it will be only one object then. Yeah.
Yeah. So one object.
Okay. Understood. Okay. Thank you.
Okay. So I will go to task number 2, which is shape detection. So let's just okay. So I'm downloading this. Okay. So likewise, in problem statement number 1, we just here have the same features. There will be angular configuration and the forces observed on that robot. And now here we are not exposing the size or shape of that object, right? So, and the objects in task 1 may not be same as that of the task 2. Okay. In this problem, we have taken 13 different types of objects. And that should be clear from the labels, right? So, and other than that, we are discussing weight of that object here. And that's it. So based on these features, the position and force values and the weight of the objective here is to predict the type of object. Are there any questions regarding this problem statement or data set? Okay, so I hope the question has.
Munib,
Yeah.
Munib, sorry. Can you go to the problem description once, please?
Okay.
No, the problem description above. Yeah. Okay. So here, robotic records at current stage. Task is to. Oh, here also there is a problem. Is it? What is the task here?
The task is to detect the shape of the object. I mean,
okay.
the type of the object here.
Sorry.
The type of the object has to be determined in this task.
The type of the object. Okay.
Yeah.
Okay. And it is labeled with the type of the object itself, right?
Yeah.
The label. Okay.
Label is there, right? So cube 1 is there, then there is ball 1. So obviously the name of the object does not make any difference, right? So you could name it anything, but it's a different type of object. So you would have to classify essentially this data into 13 different types of objects.
So in this, we don't have a slip or a crumble.
No.
Okay. Can we? So we can assume that the robotic hand has successfully picked up this up, and that is why. I mean,
Yes,
that's why their data makes sense.
Yeah. So I would like to add to that. There is an intuition that without any vision modality, the robot is able to sense what the type of object it's holding.
I see. Interesting. Okay.
Does it make sense now?
Yeah, it makes sense now. Yeah. What is that 1 and 2.13? Or what is that?
It's the weight, it's the weight of the object.
Oh, it's the weight of the object. Okay.
Is that fine, sir?
Yeah. So sorry. One more clarification. So that means the robotic. What does the time series show then? What is the significance of the time series here?
In this case, the time series does not make any sense.
Okay.
Irrespective. So we are planning of shuffling this data all over. So yeah. Unlike in the previous task, the time series there is important. Here, the time series is not important. Which obviously also depends on the type of modeling you do, right? So the participant itself could combine that same types of objects and train it separately or something. It's ultimately at the solution how the participants see this problem as, right?
Right. Yeah. So here, the intuition is that somehow the robotic hand is able to make out with one grip or many grips.
One grip.
Okay. With one grip, it is able to make out that it is a cube.
Yep.
Okay. Yeah. Okay, I understood. Yeah. And so in this problem, you will be releasing a test data set, I suppose, no?
Yes. We'll be releasing a test set today or tomorrow. So this starts pretty soon. And for shape for force estimation, the data set would be uploaded in a couple of days, I guess.
No, what I mean to say is the participant even will need two sets of data sets in the second one.
So yes, sir. So the phase means you are talking about that how we are going to release the data, right? So the how we are releasing the data remains same for both these problems. So there will be a training set which we will initially give, right? And then we'll release a test set in both these problems on which those participants will test the solutions, right? Then there will be a hidden set on which we will evaluate how the solutions. I mean, what is the performance of the solutions?
Okay. In the first data set, in the first problem, could you explain why you need hidden? Because anyway, you're not giving a label at all, I suppose. Yeah.
So we'll be changing the shape of that object in the hidden test set.
Okay, you're changing the shape. Okay, interesting. Okay.
Labels are not there, right?
All right. Yeah, I believe it would be good to even say that here, if that is okay. I don't know, according to your rules, if it is fine, then you can mention it here. You can describe the basically you can describe the test data set. That will cover everything.
Fine. Okay, sir. I hope Vinti ma'am's question has been answered. Is there anything else? Question or something? So XYZ time series for just a single force time series. Yeah, you could say that it's a single, but it's for different joints. So we have force values for 16 different joints. I hope this question is answered. Is there any question pending, ma'am?
Bhupendra has raised the hand, please.
I'm not able to see, so somebody would have to. Yeah, could you please turn on his mic? Please go ahead. Bhupendra, please go ahead with your question.
My question is, in two data set, there's a difference. In data set 2, you have multiple data points, while in set 1, you have only 2 or 3 data points.
So yeah, so this is a sample data set, right?
Okay.
So this was for the information of the participants as to how they could get a head start on the modeling approaches. So we'll be releasing the actual data sets very soon. There won't be only 2 samples or 3 samples in it, right?
Okay. It's just a sample.
Yeah, this is a sample, yeah. So if you
Got that. Thank you.
Thank you, Mr. Bhupendra. Thank you so much, Munib. Thanks to the Haptics and MEC team from IIT Delhi. And we would like to thank the India EU ICT for their support throughout. The recording will be available on the landing page, so the participants can access that. If there are no further questions, then we can close the session. Thank you, Mr. Vishnu. Thank you, professors. Thanks, Mr. Mukherjee, Alok, for organizing this, for the support. Thank you so much. Any queries can be asked on the email IDs provided on the web page. I do not see any further questions. Shall we conclude the session then? Okay, thank you everyone.
Thank you. Bye bye.
Bye-bye, thank you.